Find an equation of the line passing through the points 3, -1 and 2, 3. Now, in this problem, we're given 2 points and no slope. So is it possible to apply the point slope equation form? The answer is still yes. How? In the point slope form, all we require is 1 point, and here we are given 2 points and a slope. So point wise, we have 2 points, but we have no slope. However, we know also that once we have 2 points on a line, then we can calculate the slope of such a line. So slope m is equal to what? y2 minus y1 over x2 minus x1 equal to, if I call this my x1 y1 and call this my x2 y2, then slope y2 is 3 minus y1 is minus 1, so that is plus 1, divide by x2 minus x1. X2 is 2, x1 is 3, and that gives us 3 plus 1 is 4, divide by 2 minus 3 is negative 1, and that gives us negative 4. So we have been able to get the slope of this straight line that goes through these 2 points. Now we can apply our point slope equation to find such an equation of the straight line. So the point slope equation says y minus y1 equal to m into x minus x1. In this case, we have 2 points, 3, -1 and 2, 3. So which point do we make use of in this equation? The answer is you make use of either of them. If you make use of the first point, you arrive at the same equation as you would have used the second point. So let us take the second choice, the second point here. So we have y minus y1 is 3 equal to m, the slope, which we have gotten as minus 4, into x minus x1, or x1 is 2. So we simplify. So we have y minus 3 equal to minus 4 times x is minus 4x plus 8. And this is the equation in the point slope form. We can go ahead and rearrange this equation to get it in what we call the slope intercept form as follows. Y equal to minus 4x plus 8, minus 3 to the right becomes what? Plus 3. So y is equal to minus 4x plus 8 plus 3 is what? Is 11. So now we have our equation in another form which we refer to as the slope intercept form. I'll explain. Now m here is for the slope, which is minus 4. Of course, you see already minus 4. And the b here, I explained already in the last class that the b here represents the y-intercept of the line. That is to say, if you sketch the line that goes through these 2 points, you observe that on the y-axis, the line will pass through the point 11. Another example. Find the equation of the line through the point 2, 3, parallel to the line 3x minus 7y plus 3 equal to 0. Here, we have a line that goes through one point which we know, 2, 3. But we are told that the line that goes through this point is parallel to another line, and the line is this. So the equation is, we should find the equation of this other line. Now, we have x1 as 2, we have our y1 as what? Y1 as 3. But we are not given the slope of the line. The slope of the line is not known. Of course, if we had known the slope of the line, it would have been easy to apply the point slope form of equation of a straight line to get such an equation. However, we are told that this line, whose equation we seek, is parallel to another line, 3x minus 7y plus 3 equal to 0. And if you go back to our lectures on parallel lines, we had established that if 2 lines are parallel, then they must have equal slopes. So this line, 3x minus 7y plus 3 equal to 0. If we rearrange this equation, we will be able to get the slope of the second line. So minus 7y is equal to minus 3x minus 3, so that y is equal to minus 1 over 7 into minus 3x minus 3. And if you expand, you get 3 over 7x plus 3 over 7. So here, I divide both sides by minus 7, and I get minus 1 over 7 into all of this. And then here, I expand the bracket, or I open the bracket. So minus 1 over 7 times minus 3x, I get 3 over 7x. And then minus 1 over 7 times minus 3, I get 3 over 7. Now, if you observe, you see that this equation now has been written in the form mx plus b, which we refer to as what? The slope-intercept form. So from here, what do we say? So the slope of the line, of the second line, call it m2, is what? Is 3 over 7. Since we are told that the line we require is parallel to this line, we also know from parallel lines that the slopes of parallel lines are equal. So we are saying that since we call the first line L1, since L1 and L2 are what? Are parallel, what happens? They must have what? Equal slopes. They must have equal slopes. So what does this imply? So this implies that the slope M1 of the line which we require is the same as the slope of the second line. And what slope is that? 3 over 7. So what this means that we now know the slope of the first line as well as having one point on that line. So we can now apply the point slope equation, which says y minus y1 equal to m into x minus x1. So here our y1 is the y coordinate, which is 3, equal to m, the slope is now 3 over 7 into x minus x1. What is our x1? Our x1 is what? Is 2 into 2. So, and that is our equation in the point slope form. If you like, you can go ahead to expand the equation and also leave your equation in the slope-intercept form. We take the last example very quickly. It says, find the equation for the line passing the point 1, minus 5 and making an angle 135 degrees with the x-axis. So here we are given a point. x1 is 1 and our y1 is what? Minus 5. But we are not given a slope, no slope. So we can't apply our point slope form because we have a point but we have no slope. However, in this problem, we have been given the inclination, that is to say the angle which the line makes with the x-axis, something like this. The angle that the line makes with the x-axis, alpha or theta if you want. If you go back to our video, our lesson on parallel lines still, we had established there that the slope of any straight line can be given also in terms of the angle of inclination as what? The tangent of theta. That the slope of a straight line can be written as the tangent of the inclination or the tangent of the angle which the line makes with the x-axis, with the positive x-axis. So with this, our m is equal to the tangent. What's our angle here? Our angle is 135 degree. Tangent of 135 degree. So we now point our calculators and check. Tangent of 135 degrees is minus 1. So the m is equal to minus 1. So we have now gotten the slope of the straight line involved as what? Negative what? 1. Now we have our slope, we have our point. We can apply the point slope form equation, which says y minus y1 equal to m into x minus x1. So y minus y1 is minus 5, so that becomes plus 5 here, plus 5 equal to m is the slope, which I've gotten now as negative 1 into x minus x1. Our x1 is the x coordinate, which is what? 1. So this is our point slope equation. Of course, again, we can go ahead and open the bracket, make y the source of formula, and that becomes y equal to mx plus b. In this case, the equation would now be what? In the slope intercept form.